class, so we continue example. Okay, so in this video I will show you example. Okay, so okay, solve the equation dx dt minus 2x equal to 4. Okay, given that at t0 x equal to 1. Okay, right, so this is the question. So basically if you can see at a glance, I mean sekali lalu you tengok, we doesn't know that we will use Laplace transform, is it? But since we are in chapter Laplace transform, so I will show you how to solve it by using Laplace transform. Okay, basically in maths they have many approach or many method that we can use to solve the equation lah, to solve the solution, to solve the equation. Yes, to solve the equation. So like the previous chapter we learned about undetermined coefficient, variation parameter. Okay, so you can use that one also actually for this case, for this question. But since we are in chapter Laplace transform, so I will show you how to solve it by using Laplace transform. Okay, right? Okay, so now class, so this is the equation given, dx dt minus 2x equal to 4, and then here t0 x1 is your initial condition. Okay, so this is initial. So we just follow the steps that I already showed you in the previous one, the previous video. So you need to rewrite your equation in terms of Laplace transform. So the equation will be x prime, okay, minus 2, okay, 2x and 2x, okay, x prime minus 2x, okay, and then equal to 4. Okay, so if you use a linearity properties, you can split it. Okay, it becomes x prime minus 2x here equal to Laplace transform 4. Okay, alright. So step number 2 is step number 2 or step number 3. You need to substitute the initial condition. So from the statement or from the equation here, this way what I mean here, the initial condition. So the initial condition here state that oh class, so before that okay, suppose okay, before we substitute, before we substitute the initial condition, suppose you need to replace this one first. Okay, I think I missed out one more steps, okay, in the previous video, so make sure you listen carefully this video. Okay, so suppose before we substitute the initial condition, okay, we need to, after you already substitute the Laplace transform and so on, you need to substitute also this one, x prime. So what is x prime? The Laplace transform for x prime just now. Okay, like I said that sometimes it use f, sometimes it can use y, sometimes it also can use x. So you need to replace this one first. So by using the previous one, the equation that I show you, so Laplace transform for f prime is given by this. So Laplace transform for x prime is given by s capital XS minus x0. Okay, okay. So x prime, the Laplace transform for x prime is given by this equation. Okay, and then minus 2 Laplace x. So Laplace transform for x means Laplace transform for f lah, ft. Actually, how the proper one, okay, the proper way how to write this equation is something like this lah. You need to write xt here, xt. Actually, if you want to write is okay, and if you don't want to write also is accepted lah. But if to get more clear view, so maybe you can write t here, so means that is x prime t. So x prime t is similar to f prime t, so you will use this equation. And for this one, xt is similar to ft, so you can write fs, but now is xs lah. Okay, and then this equal to Laplace transform 4. Laplace transform 4, you can use your table directly. You can get the answer is 4 over s. Okay, you can use a table directly for this one. So now then you will substitute the initial condition here. Okay, baru you substitute. So I think for the previous video, the steps I missed out this one first. Suppose before you substitute the initial condition, you need to replace all this one first, then you can substitute the initial condition. So initial condition here is given by x 0, x 0, yeah, x 0 equal to 1. Okay, this is what I mean. What the meaning for this statement? X equal to 1 when t equal to 0. So inside here is your t, is it? Okay, that's why I just prefer lah you write t inside here. So inside here is t. So t0 x equal to 1. So you can see where's your t0. So here you have t0 at 0 1. So means that you will replace this. Okay, at 0 is equal to 1. Okay, you just substitute directly. So you just left with this equation now. Okay, class? So what next? Okay, you can see that. So the next one is you will rearrange, is it? You rearrange ys. So but for our question now is xs lah. So you need to rearrange your xs. So you can see that you have xs here, you have also xs here. So we will factorize it. So you take out xs, and inside here we left with s minus 2. Okay, 4 over s, and I bring this one, negative 1, to the right hand side. So it becomes plus 4 over s plus 1. Okay, so now the next one, we will remain xs at the left hand side. So means that we want to make it, or we want to left only xs. So it will be xs equal to 4 over s plus 1 over s minus 2. So to be more what we call tidy, kemas, so you can write like this, 4 over s minus 2 plus 1 over s minus 2. Okay, from here you can write this one. Okay, so now you already have s equal to this equation. So if you refer to the steps, so the next step is you need to find out the inverse of Laplace. Okay, the inverse of xs. So this is your ss. So now you want to find your xt. Okay, the inverse of ss means you need to find your xt. Okay, so you need to find the inverse of it. So you need to apply the inverse. The previous topic that we have learned last week. Okay, so you need to apply, either you use directly from the table. Okay, if they have no method or that you can use, I mean, if it's directly, you can use or get it the answer directly from the table. If not, you can use a convolution theorem. Okay, convolution theorem. So you can see that this is 4 over s minus 2 here. Okay, for this one, what you should do is you need to apply what? You need to apply convolution lah. Okay, you need to apply convolution. And how about this one? You can get directly from the table. So for this one, directly from table, you will get e power of 2t. Okay, class? Right? And for this one, you need to use a convolution theorem. Okay? Right? So, okay, you figure out the answer. What's the answer? So means that this is the answer that you should get. So this is the flow. Okay, the flow. So the last one is the inverse. So if you can recall, I mean, for this chapter you need to recall back lah what you have learned in inverse and so on. Okay. Okay, so like I said, this one you need to use a convolution, right? So now I want to give another one example that you cannot solve by using convolution. They have another one approach that you need to use. Okay, right? So I will continue the example in the next video, right?